So we talked about forces. We talked about Newton's second law. We talked about friction force and a spring force and gravity, and these are usually the type of mechanical forces we deal with. We briefly reviewed free body diagram, and we solved a couple of examples. Now, as you all know, equation of motion, Newton's second law, is a vector equation, and we talked about this briefly too, right? If it's a vector equation, you can divide your vectors into different components, which means you can use different coordinate systems to divide your forces into elements of those coordinate system, or your acceleration, and your acceleration in the same coordinate system, right? And I think I briefly explained, because the kinematics of particles was handled by 3 coordinate systems, it might be a good idea to handle the kinetics of particles using the same systems, because it will help you to understand the acceleration. If that's the case, you can divide force vector and acceleration vector into X and Y and Z system in Cartesian coordinate system. You can divide it into normal and tangential component, or you can divide it into R and theta in a polar coordinate system. So if you do that, as you see here, in Cartesian system, simply acceleration is AX, AY, AZ. We talked about the fact that you can separate the motion into 3 kind of independent categories of X and Y and Z. If you use normal tangential, the tangential acceleration is still V dot, and the normal acceleration is still V squared over rho, because it's the same motion, right? We just deal with what causes the motion, which are these forces. And if you use polar coordinate system, you're going to have R acceleration, AR, and theta acceleration, A theta. So these are the same things we had in kinematics, nothing new here. It's just this acceleration times mass is going to be force in that direction. This acceleration times mass will be force in its own direction. Same goes for the normal and tangential and X, Y, Z. Any question about this concept? So technically, we didn't do anything new. We know Newton's second law comes from this equation, right? And we divide it into 3 components, X and Y and Z. That's it. Or R theta or NT. Now we're going to go with the first coordinate system. As you see, the summation of forces could be in any general direction, right? Now, if it's in any general direction, when you use Cartesian coordinate system, you divide them into X and Y and Z, and same for acceleration. Practically, the problem we solved before, right here, we had our forces divided into X and Y, and accelerations in X and Y. We knew it, so there's kind of nothing new here. We already discussed this in a couple of examples, right? Now, I'm going to do a couple of more examples to see how things work here, just to give you some idea. Let's just start with this one first. You have 2 blocks. Block A is 10 kilogram, and block B is 50 kilogram. A sits on B, and they are kind of related to one another using this cord. There's friction between A and B, as you may realize that if A goes down, B goes up, so there's a relative motion between them. If A goes up, B goes down, there's still relative motion between them, right? So there's going to be friction involved here. And there will be friction involved between B and ground, which they call it C. The masses are given, the coefficient of frictions are given, By the way, these are the kinetic frictions because it's going to move. And the problem asks to determine the time needed for block A to slide 0.5 meter on the plate B when the system released from rest. So technically, this is the combination. It's at rest. You release it. It's going to move one way or another. And then we want to see how much or how long it takes for A to move 0.5 meter on B. So is the definition of problem clear? So you have two particles moving. Their motion is constrained, similar to what you saw in at the end of chapter 12. And we're going to use X and Y coordinate systems. And obviously, we're going to use friction force to analyze this. So I'm going to give you a few seconds or like a minute to draw the schematic of this on your notes. And I'm going to do it myself too. How do we solve the problem, by the way? What is the first step?
You could start with a free body diagram.
Exactly. We can start with free body diagram, but we have two objects, right? Free body diagram for which of them? We have two particles, A and B, right?
Will we do a free body diagram for block A?
Only for block A.
Would you do it for both of them?
Well, I think it makes
ones?
sense to do for both of them, as we will see shortly. So I like the thought process of Kelly. You can start with one, right? You do the free body diagram for block A or B, whichever comes to your mind first, that's okay. You start solving the problem, right? And then you may realize that you need more equations. And then you realize, you know what, I need the second free body diagram too. So you have two objects, you should get the equations of motion for both of them, right? So let me just write down the values from the, so mass A, MA is 10 kilogram, MB is 50 kilogram, mu AB is 0.2, and mu BC is 0.1. And the displacement we have, delta SA respect to B is 0.5 meter. Remember, it doesn't say block A slides 5.5 meter. It says slides 0.5 meter on the plate. So technically, your displacement is going to be respect to B, right? So if I want to do that, as you suggested, I'm going to do the free body diagrams. Let's do for both of them. I'm going to put A here. Let's just use the same colors. So we kind of, this is block A. And this is block or plate B. right? Start with A. What are the forces acting on A?
Gravity, friction, normal force.
Okay, let's just go one by one. Gravity. So I'm going to have MAG. Then you said normal force. I'm going to put normal force with green. Fn. Remember, this normal force is between A and B. So I'm just going to call it Fn AB. Right? Now friction. Should I get the friction upward or downward? Friction is obviously in this direction. Should it be this way or this way?
Up.
It should be up, like this. Now, as I said, friction always opposes the motion, right? If we release this, is block A gonna go down or is gonna go up? You may not know, but considering MB is 50, MA is 10, you have the heavier stuff in the bottom, it looks like B goes down, A goes up. If A goes up, the friction is going to be which way? The opposite of that direction. So that friction force is going to be down. Okay? And that's how you analyze friction. As I said, you cannot guess and randomly select. For reaction forces, if you do not know what's going on, you can do it. Sometimes for some parameters, but friction has to be properly set up. So if that's the case, this is going to be FF AB. Let's put it this way, right? What else? That's it, right? Or is it?
And the force of the line from the pulley.
Yes. Let me just change this with orange. The force that is applied to A from the cord or the cable, whatever you name it, and obviously cords can only apply tension. They cannot be compressed. So there's going to be like T, right? That's what we have for A. Any other thing? Remember, when you create free body diagram, you separate it from the environment. If I cut this cord, I'm going to put this force. If I separate it from here, I'm going to put this two force. And of course, if I separate it from Earth, I'm going to have gravity, right? There's no other interaction of A with anything else. So this is what we have. Now we go to B. I'm going to start with the tension T. Tension T is going to be like this because, again, applies that the cord can only tolerate tension. We have gravity. I'm going to do with red because this is the red box. MBG. What else? Remember Newton's third law, action, reaction. So when B applies this friction force and this normal force to A is going to apply exact same forces in opposite direction, right? So I'm going to have a normal force from between A and B. Oops. Sorry. I'm going to have Fn AB here. And I'm going to have friction opposite direction FF AB here. Do we have other forces? Yes. Jake, what is the, or what are the other forces, potential other forces? We need to look at interaction of B with ground through this surface, right? I think they call it C. So let's just call this C. So interaction of B and C, B is light on C, so you're going to have a friction. If A goes up, B is going to go down. And if B goes down, the friction is going to be opposite direction, right? So we will have a friction force going up, F friction BC, right? And there's a normal force between B and C. Fn BC. Any other forces? Now that we have all forces for A and B, I'm going to write the equations of motion. Anything missing in this free body diagram or the two free body diagrams?
Coordinate system.
Coordinate system, because I want to write the equations, summation of forces in X, F, excuse me. Let's say write summation of forces in X equals MA AAX, summation of forces in Y, and this is for block A, right? MA AAY. Now I don't know what is X and Y, so I need to have a coordinate system. I'm going to use this coordinate system for both of them. This is X, this is Y. Right? If that's the case, I will divide the forces. Apparently, every force except gravity is in X or Y. This is X, this is X, this is Y, and here, these are X, Y, and X. The only force that is not in X or Y is gravity, right? So you have to get the component of force in that direction. I'm going to do it for first one. This is going to be X component. This is going to be Y component. The angle here is 30. So if I rewrite these equations, you're going to get P minus MAG sine 30 minus FF AB is equal to MA AA. Because it's only X direction, I'm not going to put X, just AA, right? Because you don't have AY is going to be 0. It makes life easier. Is this correct? Friction here, P here, and gravity here, all three X components of the forces, right? And for the second one, summation of forces in Y apparently is not going to go up and down. This will be 0. So you will get Fn AB minus mg cosine 30 equals 0. And this is going to give you f and AB is equal to mg cosine 30. I'm going to call this equation 1, okay? Now, I do the same thing. You know what? Let's just go one more step. Because this is kinetic friction, FFAB is going to be mu AB Fn AB. And if you substitute here, FFAB will be mu AB MA G cosine 30. I'm going to substitute this number into equation 1. So T minus MAG sine 30 minus mu AB MAG cosine 30 equals MA AA. And this is the final equation I get from here after implementing all those details. Equation 1, right? Any question about this? Any of you cannot do this? Now I will do the same thing for block B. Summation of forces in X equals MB ABX. Summation of forces in Y equals MB ABY. And because it doesn't go up and down, we know that ABY is 0. So that makes life easier. Now, which direction B moves? Up or down? If A goes this way, B is going to go this way, right? So either you can consider this as positive or you just go with the signs. This is like AB technically, right? So you're going to get T plus FFAB plus FFBC. Let's just move this down a little bit. Right? Minus MBG sine 30. Again, if you look at here, you're going to have two components of mg. This is the x component, and this is the y component, right? The x component is going to be mg sine theta, and we don't have any other x, so this is going to be equal to mb minus AB, because we know AB is negative going down, right? For the second one, you have Fn BC minus Fn AB minus MBG cosine 30 equals 0. And if you simplify this, FNBC is going to be MBG cosine 30 plus FANB, which was MAG cosine 30. So if you simplify this, FNBC, it's going to be MA plus MB G cosine 30. Any question up to here? Now I'm going to find the friction force between B and C, FF BC. It's going to be mu BC. You remember friction is coefficient of friction times normal force times this. And I can substitute friction force for A and B. Friction force for AB, I have it. Friction force for BC is this guy. So if you substitute that, equation 2 will become P plus mu AB MAG cosine 30 plus mu BC MA plus MB G cosine 30 minus MBG sine 30 equals to minus MB AB. I can multiply the whole thing by a negative to make this positive. So if I do that, we're going to get MB AB is MBG sine 30 minus T minus mu AB MAG cosine 30 minus mu BC MA plus MB G cosine 30. And this is going to be your equation number 2. Okay. You could stick with this guy, but just to make sure we understand, AB is negative, I put the negative signs there, and then any question? Now, I'm going to bring this second equation down here. I'm going to bring this equation down and put it side by side, see what happens. Let's just grab this whole thing. Right? And we may want to get rid of this line thing, so we have 2 equations. We need to see how many unknowns we have here, right? What are the unknowns in this problem? You guys need to tell me what are the unknowns. Like Kelly,
Tension.
you give me one unknown, I'm going to ask the others.
T.
T, okay, you took the easy one. Now, Andrew, you were saying something? I stop you.
I was gonna say tension in mu of BC.
Mu BC, no, the mu's are given.
Oh.
If you go to the top, mu BC and mu AB are given. Those are like physical parameter. What else? Kelly took your easy answer, so. Ricardo, Haushen, Izzy, Yo.
I'll say acceleration of A.
Acceleration of
A.
A. Yeah, we don't know this. That's it. If we don't know acceleration of A, we also don't know acceleration of B, right? So technically, everything else like mass, G, sine, mu, everything else is known. So technically, we have 3 unknowns, right? And we have 2 equations. How do we get the next equation? You remember this geometry? The core thing, the concepts we had in chapter 12. You're supposed to remember chapter 12 from Monday, right? And you had a quiz today. This could be your quiz. How you relate acceleration of B to A. I'm just going to write it down here. If this is SA and this is SB, right? You can say SA plus SB equals constant, which means VA plus VB is 0 and AA plus AB is 0, right? Which means AA is minus AB. And we know, you see, as SA becomes smaller, SB becomes bigger, so they have opposite signs. We already considered the negative sign in, so it's just a value, right? Here, we had negative sign, so whatever you have for AB should be the magnitude of AB, right? Because we already considered that. So technically, you can say AA, the magnitude is same as AB, right? So if you do that, you just can simply consider it as acceleration. So if we do that, I'm not going to rewrite the equation. I'm kind of lazy. So I'm going to just erase this A and this B here, right? So you get 2 equations, 2 unknowns. And if we solve, I'm going to give you a couple of minutes to solve this. Remember, when you write this, you neglect the direction stuff, just the magnitude, okay? If you solve this, I guess you can complete it later because I want to save some time. If you solve this, A is going to be 1.854 meter per second. And the tension is going to be 84.58 Newton. Remember, AA is minus AB, and that's how you get it. Considering A decreases, the displacement SA decreases, we may just put it this way. AB is minus AA equals 1.854, which means AA is minus 1.854 meter per square second, right? Because A decreases. At least we know their opposite direction. Any question up to here? Now the problem asks you to find the distance. I'm just going to go back here. The distance that the distance that A goes on B, which is relative distance, right? So technically, you may say S A respect to B is equal to SA minus SB, and then the displacement delta SA respect to B is going to be delta SA minus delta SB, right? How delta SA and delta SB are related? Considering this equation. Can I say from SA plus SB is constant, that delta SA plus delta SB equals 0, which means delta SA is minus delta SB. And if I substitute here, or delta SB is minus delta SA. If I substitute here, delta SA respect to B, it's going to be 2 delta SA, right? And this is 0.5 meter. Which means delta SA, the actual absolute value of delta SA is going to be 0.25 meter and goes up, right? If this is the thing, the absolute displacement of this is 0.25. The absolute displacement of this is 0.25, right? And the relative displacement is 0.5. Any question up to here? So I'm using the relation, the relative motion and the constant motion, combine them to see how much actual displacement of A or B is. I think the problem asks for the time. The time, yes. So I have delta S and I have acceleration. How I can find T? And this is motion on a straight line. Any suggestion, any equation? From early part of chapter 12? So can I say delta S is V0T plus A T squared by 2? Because it's constant acceleration moving on a straight line. And if I do that, the whole thing starts from rest. So a V0 is 0, which means then your T is going to be 2 delta S divided by A square root. And if you calculate that, 0.25 times 2 divided by 1.854 square root, and you should get your time as 0.519 seconds. So it takes almost half a second for A to slide half a meter on B. Any question about this? So I think this was an interesting problem, kind of giving you different perspectives. I'm going to go back to the schematic, right? Let me clean up around these things a little bit. To review what we have done for this thing, okay? Okay, whatever. So to analyze this, first, we needed to get free body diagram for each of them. So we had, for the free body diagram, excuse me, we had interactions in this surface and we had interactions in this surface. And of course, we had two free body diagrams, one for A, one for B, right? That was the first step. We got all of that. We wrote the equations, we simplified them. Then we came back to the point that we need one more equation to find the unknowns. Then we used the constraint motion between the two. And using this constraint, we developed a relation between delta AB and AA, right? They're technically equal in opposite direction. After that, when we solved it, to find the time required, we had to go to relative motion analysis, right? Because B and A move relative to one another, and technically the relative displacement is what we're looking for. When we get this again, we went back to this equation, find out that the absolute displacement of A and B is equal, and we solve it. So technically, we use kinematics a little bit. We consider the friction force between multiple objects, and we develop multiple free body diagrams. So this should give you different perspectives of how you solve problems like this. You had the cord tension in the cord, which is equal from two sides of the pulley, right? All of that. Any question? You're good? Okay. So let's go back to the slides. We can solve this example, but this is almost similar. You know, you have friction and forces here. So I'm not going to do this one. If you're, by the way, I usually have more problems that we can solve in the slides. We're going to skip some of them, right? Some of them I may give you as bonus homework. Some of them we may not touch it. I recommend you, when you go home, solve those problems too, right? And if you have questions like anything else, you can ask me, okay? But if you skip a problem, it doesn't mean we are missing something, because I usually put more examples and solve some of them, you know, depend on, you know, the flow of the class and things like that. So the next coordinate system is normal tangential. If this is the path of motion, the tangential is obviously tangent to the path. Normal is perpendicular that toward the center of the curvature of the path at this point. If you have a combination of different forces, you can add them up, create one general vector force, and then you can divide that vector force into T and N direction. Remember, normal acceleration always toward the center, so you have always get it this way. Tangential acceleration toward the motion, you may have negative acceleration, your summation of forces could be backward, but this is general two directions that you divide your forces. similar to XYZ we just did, right? If you do that, you get your equations. Summation of forces in T is MAT, which is V dot. Summation of forces in N is MAN, which is V squared over rho. And that's it. Remember, these are the positive direction. And usually when an object, a particle moved on a path, there's a normal force always in normal direction, obviously. I'm going to do this example to see how it works. It's a simple like pendulum. So you have the length of the cord, you have the angle, you have the mass. It says this ball has a mass of 30 kilogram and a speed of 4 meter per second at the distance when theta is 0. So technically, if this is theta, theta 0 means this vertical position. Right here, the ball has the speed of 4 meters per second and moves freely here. Of course, freely means there's gravity, there's a tension here and stuff like that. We want to see when theta is 20, how much is the tension in the cord. So I give you a minute to draw this. How we're going to solve this one? Any suggestion? Okay, as you see, this is the initial position, this is the final position, like initial and final. So we need to get a general equation to see how forces act here, right? As we talked before, anytime you have this kind of motion or this kind of equations, the first step is what? Free body diagram, right? So I'm going to draw a free body diagram for the ball. Let's say this is the ball. What are the forces acting here? We have gravity. And we have tension in the cord. Right? This is my free body diagram. I also need to have my coordinate system. It might be easier to use normal tangential. So I consider like this as ut and consider like this as un, okay? And I think we need to cut it short. We don't need all of that. Just like this, okay? How I'm gonna get the equations, we're just gonna write down the way they are. Summation of forces in N, M, A, N, which is M, V squared over rho. Summation of forces in tangential direction, M, A, T, which is M, V dot, right? And V dot is technically tangential acceleration. We can keep it that way. Either way works. Let me ask you this question. At the beginning, this guy is here, right? Is here. And it has this velocity. And then moves here and gets another velocity. Is the velocity constant? Yes, no. Someone tell me before I call.
No.
No. Is that, so obviously it has acceleration, right? Is acceleration constant? We may not be able to say it right now. So let's get to the equation and see what happens. These are the two equations. Now, in normal direction, we have two components of force. One is T, and the other one is the normal component of gravity. If this angle is theta and this is theta, so in N direction, you're going to have T, which is positive, minus mg cosine theta is equal to mv squared over rho. And rho here is just a constant. I'm just going to write it L. This is technically your rho, the radius of curvature, which is constant. It's like moving on a circle. Make sense? Okay. So let's say this is 1, this is 2, this was 1, and I'm going to write 2. In tangential direction, as you see, we have this component, right? And it's negative because this is positive direction, right? This is positive direction and this goes this way, so it's negative. Minus mg sine theta equals m at. And if you simplify this, your at is going to be minus g sine theta. Now you can answer the question, is the tangential acceleration constant? What you see here, it depends on the angle theta, so it's not constant. If I look at equation 1, from equation 1, I can determine t. I'm looking for t, right? I'm going to write t is equal to mg cosine theta plus mv squared over L. What are the unknowns here? Obviously, t is one of the unknowns, right? I don't know it. Is there anything else I don't know? Theta Problem says at 20 degrees. So theta I know. M and G I know. L I know. How about V? Do I know the velocity? Right here. Do I know that velocity? No, I don't know it. I know initial velocity, but apparently because there's an acceleration, as the particle moves through this path, it's going to change its velocity. And because this acceleration is negative, it's going to slow down, right? To find t, we need to find the acceleration. And how we do that? Sorry, we need to find the velocity. How we do that? I have the tangential acceleration, and this is the path of motion. Can I use kinematics and relate the path of motion, delta S, acceleration and velocity? Is there any equation in your mind that relates? I try to create, kind of loudly think and give you my thought process. I have acceleration. I have this path of motion that I draw with green, and I need velocity. So is there any equation that relates velocity, acceleration, and displacement from kinematics? You guys are supposed to know this. Any of this could be your quiz problem, right? I think I gave you a really simple quiz. So you didn't use any of this. Actually, you should have used that equation in your quiz. You remember this? Right? And if this S is the length of the curve, this could be AT. Can I do that? Just analyze the motion as it goes here. Right? If I do that, I can integrate it easily, right? Integration of V dV from V0 to V, because we go from V0 here to the final V here, right? Equals to integration of AT ds. But this is the problem. The tangential acceleration is given as a function of theta. This integral is a function of s. Is there any way that I can relate s to theta? Because if I substitute that, let's just do one more step. If you do that, you're going to get, okay, from the left side, you're going to get v squared by 2 minus v0 squared by 2 equals integration of at is this guy, minus g sine theta, and then ds. You cannot integrate theta in terms of s. So either you have to turn theta to s, or you have to turn s to theta, so you have one variable. How we're going to do that? Any idea? Let's just cheat a little bit. If this is your S, and this is R, and this is theta, how we can relate S to theta? You need to remember this from your, I guess, high school geometry.
S equals R times theta.
Yeah. When I ask questions, it doesn't have to be complicated. I know most of you know this, but you may think of something complicated. Okay, S is R theta, right? If I take the differential, ds is going to be R d theta. And in my case, R is L. So technically, ds is L d theta. I'm going to substitute this ds here, okay? And my integral becomes simpler. So v squared by 2 minus v0 squared by 2 equals integration of minus g sine theta L d theta. Now, this could be if S is from 0 to S, because this is the length of the S. But now that you turn it to theta, you go from 0 to theta, which is going to be equal to 20. But I'm going to do it parametrically. We can substitute 20. It could be at any angle. Let's just keep it general. I want you guys to get this integral and give me the answer. 30 seconds. Right? So what did you get? So you should get GL cosine theta, right? From 0 theta. If you substitute, you're going to get GL cosine theta minus 1. So technically, your V square by 2 is going to be GL cosine theta minus 1 plus V0 square by 2. Or if you simplify it, V square is going to be 2 GL cosine theta minus 1 plus V0 square. This is your V square, right? Did you get the same number or same equation? Now at theta equals 20 and V0 equals 4, you're going to get your V, and L is also 4 meter, I suppose. Is it 4 meter? Yeah. Your V square is going to be, or let's just get the V. V is going to be 3.357 meter per second. And if I substitute this value into this star equation, I'm going to write the star equation one more time down. So your T is mg cosine 20 plus mv squared over L. And if you substitute those values, m is 39.81 cosine 20 plus 30 times 357 square over 4. And if you solve all of this, you should get your T as 361 Newton. That's what you get. Any question about this? So again, to review this, are you guys done writing? Okay, to review this, let's start from the beginning. I have these things coming from here to here, right? And the free body, the best way to do it is to do normal tangential, right? So the problem was to find v squared over rho, we did not know the value of this. So we had to integrate acceleration and relate it to velocity over this displacement, right? So we got that from, again, from kinematics. And then when we got that equation, we also had to go back a little bit to the geometry part of the things to remember S is R theta. Remember, we're going to have to use this quite frequently, right? So if you didn't remember it or wasn't clear now, you should remember this for the next few weeks and hopefully for the rest of your life as engineers. And then we switched from ds to d theta so we could complete this integral and solve it. It was general, the problem asked from 0 to 20 degree, but you can go to any angle, 45 degrees, 72 degree, I don't know, 125 degree, whatever you want to go, that's okay, right? So you can do it that way. So this showed, could I use X and Y coordinate system? Possibly, but remember, again, when I have normal tangential, this S and the relation of, like V dV is equal to AT ds, this was key to solve the problem. If I was going to go with X and Y, things would have been much more complicated to solve, right? So that's how you look at the geometry of the problem and you decide what coordinate system you're going to do. Okay? Any question? You guys are very quiet, so are you bored? I mean, you should be bored because it's online and you look at the screen for like almost 2 hours, but I hope the passion of learning overcomes the boring part of the thing, right, Ricardo?
Hey, can you explain why rho became 4? I just don't really know
because you see, in a general case, this is rho, right? Radius of curvature. In this case, when you have a constant length, technically it moves on a circle. So everywhere rho is R, which I call it L, which is the length of this chord, right?
Okay.
Or meter.
That makes more sense. Thank you.
Mm-hmm. Any question? Other question? Can you do something like this in the quiz? Not now, maybe with some practice. But remember, you're going to go through the similar steps. You're going to do similar problems. The overall concept is going to be the same. Now, let's do one more example here. And that also comes back to the friction stuff. You have a guy lying down against a wall which has a variable angle, and this guy is going to rotate around this axis. So because this is a guy, we use the center of gravity. You already know it. We're going to talk about it later, but you can consider this guy like a particle, right? Like a small box here, or whatever you name it. The distance of that particle from the center of rotation is 8 feet. And this angle could change. You have coefficient of static friction as 0.5. And as this rotates, you could change this angle. The speed of the guy is constant, 30 feet per second on this circular path. You want to find the smallest angle of the cushion at which he will begin to slip off. So technically, you want an angle when this guy, you can visualize if this goes too fast, the guy could slip off and just kind of shoot outside, right? Can you visualize that? If it goes too fast, this is going to go off. If it goes too slow, and this is vertical, the guy is going to fall down. So here it's critical to have the friction in a proper way. So it says he will begin to slip off, so he may go off from here, right? At certain angle, we want to find that angle. So to solve this, you have an axis of rotation, and you have this particle, let's just call it particle. I can show it like a box or something. The weight of the guy is 150 pounds. Remember, this is the weight, is not the mass. So mu s is 0.5, and the velocity is constant, 30 feet per second. This radius is 8 feet, and you want to find theta that causes slipping outside this, and this is your theta. Let's switch to the slides. So to be able to visualize this, let's just, obviously, this guy is moving on a circular path, which kind of looks 3D. Let's just draw something like that. So technically, moves on a path like this, right? We are looking from the side. This is the radius of the motion. This is Z direction. If you want to have normal and tangential coordinate system, this is going to be UN. And you may realize that UT is perpendicular to the plane, to the paper, you know, the plane of your paper or my tablet, right? So it's technically perpendicular to that. Can you see that? When you look from the side, the tangential direction is technically tangent to this guy, which is horizontal going inside your paper. I don't want to draw it this way because this looks vertical, so let's just keep it with that visualization. If that's the case, I'm going to start with free body diagram. This is the guy. You have gravity. You have normal force. And you have friction. Now you guys tell me, is the friction coming down or going up? Is it this way or this way? Again, if this goes too fast, the guy is going to jump off the system here. Remember, the guy does not move with respect to that cushion, right? So it's practically a static friction. But if it, I don't know if you guys can see my hand. If this is the object, let me find a small object. If this is the object, right, and rotates, if it's going to go off, it's going to slide up, right, going out. If it goes out, which direction is friction? It has to be down, right, opposing this. So if that's the case, we are going to have our friction force this way, right? Now, considering it goes with constant speed of v, how much is your tangential acceleration? It's going to be 0. So if I write the equations of motion summation of forces in T, it's going to be M-A-T summation of forces in N, M-A-N. And because this is 3D, summation of forces in Z, M-A-Z, right? The tangential acceleration problem says it's 0. Practically, you don't have any force in T direction. So technically, no force, no acceleration, everything gone. In the normal direction, you have components of normal force and components of friction force, right? And if this angle is theta, this is going to be theta, and this is going to be theta. So if I write, let's say equation 1, 2, 3. 1 doesn't give us anything because 0 is 0. Equation 2, you're going to have FF cosine theta minus Fn, sorry, plus, because both of them are, you see, both of them are toward the center and are positive. Fn sine theta equals m v squared over rho. Again, I can write rho with Ricardo, or I can simply write r because my rho is constant and is r. Okay? It's a circle, so radius of curvature is constant. If I write equation 3, then I'm going to have Fn cosine theta plus, or sorry, minus FF sine theta minus mg equals to, how much is AZ? Acceleration in Z direction. Does this guy go up and down? Remember, it says, what is the angle at which it starts to slipping out? So before that, it doesn't slide or slip, right? So technically, it doesn't go up and down, which means your AZ will be 0, which means this guy is simply 0. I have two equations. How many unknowns we have? I don't know the friction force. We're going to talk about that, how we find it, right? But in this equation, I do not know the friction force, the normal force, and theta. So we have two equations, 3 unknowns. We need to find the third equation. You remember I said, when we have a static friction, we don't know how much it is unless it is right at the maximum border, right? This problem says, find the theta at which the guy starts slipping. So before slipping is the maximum friction, right? Maximum static friction. So if that's the case, your friction force, which is maximum static friction force, is going to be mu s times Fn. I'm going to substitute this into those two equations. So you're going to get mu s cosine theta Fn, and I can factor Fn too, plus sine theta Fn, this is equation 1, equals m v squared over r, and here cosine theta plus minus mu s sine theta Fn equals mg. Two equations, two unknowns. How are we going to solve this? A hint is you can divide the two sides of the equation to get rid of Fn. Which means this divided by this equals this divided by this. If I do that, from the left side, you're going to get mu s cosine theta plus sine theta Fn divided by cosine theta minus mu s sine theta Fn equals mv squared over r divided by mg. Now, I'm not going to continue because we're almost done with the time, but if you cancel out this and this and this and this, all you have is an equation in terms of theta, okay? Any question about this up to here? So on Friday, we will finish this and continue with the rest of the concept, okay? I will grade your quizzes and homeworks maybe by weekend, or maybe I can finish it by Friday because we don't have teaching assistants for summer courses anymore. So I'm going to have to do it myself. So I'll probably find a time to do it. And so you can get a feedback on your quiz, okay? And meanwhile, I will post homework for chapter 13 so you can start solving some of those. Because when we finish it on Friday, your due date to submit your homework will be next Monday, okay? And similarly, we're going to have the second quiz next Wednesday covering chapter 13. Looks good? Okay. I try to give you a couple of quizzes. Maybe if we can, we do quiz from each chapter if the time allows and the timing. But again, if your homework is due on Monday, you guys need to submit it by Monday so I can post the solutions on Tuesday. So you can, check it and get ready for Wednesday, right? Okay, that's it for today. Thank you very much. Enjoy the rest of your day, and I see you guys on Friday. Bye.